Hey, hi everyone. Uh, I welcome you all in today's expert talk series. We have Sumit with us, who would be guiding you on today's session. Uh, it is on deep dive into cross regional load balancers on Google Cloud. If you are a beginner, then this could be a good starting point to learn about one of the key topics and services of GCP, how Google has designed load balancing in general, what are various type of load balancing. Talking about Sumit, he is an expert in the industry on GCP. He has a variety of GCP certification. He is presently working with Orange Business Services. He has around 15 years of industry experience. I welcome you, Sumit, in today's session. We at GDG Cloud Bhopal have planned the series so that we can bring uh, various GCP experts from the industry for you so that they can enrich you all with their industry experience, their expertise they would be sharing with you all. So I would not take more time as I would much looking forward to Sumit what he has to say about on cross regional load balancing, and later he would be showing you a demo as well. So I would hand over now to Sumit.
Thank you, Mayur, and thank you, GDG Bhopal and the organizer for having me here and giving me this online platform to share my knowledge and experience with the people and the communities. And I think this is a great initiative for the expert to share their experience and discuss the real world industries use case here. So, thank you. And also, thank you to everyone who is joining this session. So, welcome everyone. So before I get started, let me open my presentation and let me introduce myself. So my name is Sumit Kumar. I am having 14 years of experience. I'm a multi-cloud solution architect, works with Orange, and I'm living in cloud since 2016. I started my cloud journey since 2016, and I'm expertise in GCP and also work for the other clouds like AWS and Azure, and I am 7 times multi-cloud certified. Um, and last year, I got a chance to nominated for the AWS Community Builder. So I became a AWS Community Builder around in July, August. Um, Apart from this, I in my free time I also love to share my knowledge and experience on cloud DevOps and artificial intelligence by writing the contents on Medium articles and share with the peoples. And recently, I started my YouTube channel for uploading videos on Google Cloud, specifically on the Google Cloud Advanced series on networking and some sort of Terraform, Terraform series. If you want, you can just find me with this name, the Cloud Baba without space, and you can connect me over there. And they are very cool and amazing videos you can find, which will help you to gain a lot of good knowledge on the cloud. And the mentorship, I love to connect with the students and the beginners and professional to share my knowledge and experience and guide them for their cloud career path. So that is what about my introduction, and there is a barcode here. If you want, you can connect me by scanning this barcode, and I would love to help you or guide you on the cloud journey. So you can, if you want, you can just simply scan it. Otherwise, in the end of the slide, you can also scan it. Okay. So moving ahead, this is the agenda of today's session, where we are going to talk about cross-regional internal application load balancer. What is cross-regional internal application load balancer? This is something new, new service, and still in the preview mode. because earlier we are as of now we are using the regional internal application load balancer in most of our use case and industries and in the real world, right? So this is something new that we are going to discuss today, and what challenges that this service is going to solve, which regional internal application load balancer doesn't. Okay. So when I say preview mode, the preview mode allow Google to gather the values feedback. Basically, a preview mode is not in your is for the general availability. This is not in production. Google basically launched this in preview mode first, and it gets the feedback and helps that Google identify bugs, improve the usability, and prioritize the your features for the development. So remember, not all the Google Cloud service go through a preview phase. Some may launch directly into the GA mode, right? So before I deep dive into the cross-regional internal application load balancer, let me just talk about the agenda. What is the agenda of today's session? So we are going to first talk about what is a cloud load balancer in general and in Google as well. And then the load balancer types, we have external load balancer and the internal load balancer. We will see that. I basically am going to cover the the basic or the quick walkthrough of the load balancing, right? Because load balancing itself is a very complex topic, right? So we cannot cover it in one go. Then we gonna use how to choose a load balancer in a Google Cloud, and the application load balancer overview. This is a layer 7 load balancer. Generally, all the cloud provider offers two types of load balancer, a layer 7 and layer 4. So this is a layer 7 load balancer. Then we see what is 3-tier web services, and what is internal application load balancer overview. And then we will see our main agenda, what is cross regional application load balancer. So first you understand all these things, then you will be able to understand why cross regional application load balancer is required. And then we will find the conclusion and we'll end with the demo and questions. All right. So what is a load balancing? So a load balancer, it distribute a user traffic across multiple instance of your application. So the user's traffic can be an external or it can be an internal traffic, right? So in this diagram, you can see that on your left hand side, the web clients and the internal clients. It can be external web clients or it can be an internal client, right? So whenever a traffic is hit to your load balancer, it distributes the traffic to your backend instance. So why do we use a load balancer? We use a load balancer to scale our application, right? To scale our application, to make our application reliable, right? Because when you get a high traffic, you need some sort of device that can be used to distribute the traffic amongst your web server or backend service, right? And that is why we use a load balancer. So Google Cloud Load Balancer or balancing is built on a reliable high performance technologies, which is called a maglev or Andromeda. So basically Google front ends and Envoy, we can call it the same technology that Google is used to run their own product like Gmail, YouTube, and there's a lot of product. So external versus internal load balancer. What is external load balancer? What is internal load balancer? It's very clear with the name. When a user traffic is coming from public or internet, then it's called and it's hitting to your application, then you should use an external load balancer, right? Because external load balancer is the one which face your public request or your external request from the internet, and then it forward to your backend servers, right, within your network. So this flow of network is going to be accompanied by the external load balancer, right? And here you have an internal load balancer, where the user is or the client is sending a traffic from your network. The source is going to be your network, And the load balancer, you should use an internal load balancer, right? Because this internal load balancer will get a front end which will be having a internal IP. So if I talk about the definitions, the external load balancer basically act as a gateway to your resource and accessible from your public internet, and it typically has a public IP, right? That clients of your outside use to send the traffic to your backend service. Whereas on the sorry, whereas on the internal load balancer, this operate within your private network and distribute the traffic between instance within the same VPC or VPC network, right? So it has got a private IP address and it is not directly exposed to the internet, right? So whenever we design any architecture or any sort of services, then
Sumit,
yeah.
are you sharing the slides? It is not visible if you are sharing.
Oh, sorry, I think I missed it. 1 second.
Huh. I thought so.
Okay,
Mm.
I think I missed
Now
it.
the screen
Yeah.
is visible. Yes.
So is it visible now?
Yes, it is, Sumit.
Okay. Sorry. Okay. So I missed some of the slides. No worries. So here we talked about why cross-region internal application load balancer. So this is the agenda of
You
this
can continue
discussion.
from there on itself.
Yeah, yeah. So I was talking about the load balancer. What is load balancer? External versus internal load balancer. And so external load balancer, right? So it is required when a traffic is initiating from the from the internet, and the internal load balancer is used. We should use when a traffic is initiating from your private network, right? So let's go ahead. So where should we use this external load balancer and internal load balancer? Let's say this is a very familiar and mostly widely used three-tier web services that almost all company use, wherein we have web tier, application tier, and database tier. So you can see in this design we have three tier. The first tier is called a web server, the second tier is called an application tier, and the third tier is called a data backend tier, right? So here we are using a external load balancer so that the traffic can be consumed here from the external users, because your website tier is always a front end, so you should use an external load balancer here. Now the traffic is now the traffic is from your web server, uh, is going to flow to your data, sorry, your application server, where you should use an internal load balancer, right? Because your traffic is now initiating within your network, right, from the web server. And from the application server to your database server, we should use an internal load balancer because the traffic is initiating from the application load balancer. So this is how you can mix external load balancer and internal load balancer in your architecture to design your system, to design your cloud-based system design, right? So types of load balancer, I already discussed. There are two types of load balancer. We have application layer 7 load balancer, and we have network load balancer. And again, application load balancer layer 7 has two types, external application and internal. And layer 4, again, it has two types, external and internal. We are not going to talk about layer 4. We will stay focused on L7 only. So choose a load balancer. So here, this is the diagram that you can use to choose your load balancer from the Google Cloud offering, right? So you can see that almost nine types of load balancer you can use depending on your business use case, right? So on your left hand side, you have a application load balancer. On your right hand side, you have a network load balancer, which is a layer 7. So application load balancer, again, of two types, external, internal. And external can be two types, global and regional. And internal can be two types, regional and cross regional, right? And similar pattern you can see here in the L4 or network load balancer, TCP load balancer, right? So let's just focus on the application load balancer and focus on your internal load balancer, right? So in internal load balancer, you only have this regional load balancer as of now, that industries are using, and which is a regional in nature, right? This cross regional load balancer is recently introduced and still in the preview mode, and this is the one that we are going to cover today, and why should use a cross region over the regional that we are going to see ahead, right? So let's move ahead. Okay, so this is the internal application load balancer regional, right, which is currently used by everyone, right? So this is the overall design, which is a layer 7 load balancer, and this load balancer is basically use the internal IP address at the front end. So if you see at this architecture, the clients are internal, right? So clients are sending a request over HTTP or HTTPS to your internal application load balancer, and the traffic gets terminated over here, and the new connection from the load balancer gets initiated to your backend service. So this is how your traffic is flowing from your clients to your backend service, and you have to make sure that in the regional load balancer, the client and the backend has to be in the same region, right? If your client is hitting from a different region, then it is not possible. The second client in your second region cannot reach to their internal application load balancer, right? And that is where we should use a cross regional internal application load balancer. I'll come to that internal cross region. So as a mode of operations, it can have two types. There is the regional internal application load balancer, which is the one that we have just discussed, and the cross region preview, which we are going to discuss in the next slide. And which basically cross region ILB supports global backends and globally accessible. So clients from any region can send the traffic to your load balancer, which we will see in the demo, right? So let's see the differences. Okay, so let's just see here. We are using the internal application load balancer regional in 3 tiers. So here you can see that you have a 3-tier architecture, where you have an application external load balancer, and the traffic sending into your front end in a different region, and then the traffic is flowing to the application backend and the data backend using the internal application load balancer, the regional internal one, right? So what is the problem here? What is the issue in this architecture? Well, when the user is getting a request from the application load balancer, the application load balancer distribute the traffic to the front end based on the proximity or the user's location, right? But when a web server or the front end server forward the traffic to your application backend server, the problem is that it is using the regional internal application load balancer, right? So what happen if your internal application load balancer goes down, or let's say your application backend application goes down, then what happen? The user will not be able to get see your web page, right? It will throw an error because there is no backend service, right? So from here you cannot fail over to the another region. Similarly, in the US Central one, you have a regional internal application load balancer. In the US East one, you have a regional internal application load balancer. If any of this application internal application load balancer goes down, then it cannot fail over to another region, and that is where cross region application internal load balancer comes into picture to defend this issue, right? So we'll see that. So basically, if we just remove these three internal load balancer, and we just set up our cross region internal application load balancer, just single application load internal application load balancer with three front end, it can do a failover, right? We will see that. So now, what is cross regional internal application load balancer? This is the main agenda, the agenda of this today's session, which we are going to see. So when we use a cross-regional internal application load balancer, you will get a global backend service, right? Whereas in regional, you get a regional backend service, right? So cross-regional internal application load balancer improves your service availability by creating a global backend service with the backends in the multiple region. So you can see that this is your load balancer, and the global backend service, which is in which is targeting your multiple backends in US West 1 and US East 1, right? So here the client is sending the request to your load balancer, which will get a two front end. It is a single application internal load balancer which is getting a two front end for US West 1, and one is for and another is for US East 1, and it is sending the traffic to your backends in a multiple region, right? So it front ends the VIPs in two regions, right? US West 1 and US East 1. And you can use the DNS routing policy to return the optimal VIP to your clients, right? So we will use how you can use the DNS manager policy so that it can send the traffic depending on your users location, right? So cross-region failover if the backend in a particular region are down or during the entire regional outage. So let's see if this entire region US West one go down. Then what happened in this case? The client VM will continue to get served from the backend machine from the US East one region, because this is a cross-region internal load balancer. It can fail over to the another region, but that was not possible in your regional internal load balancer, right? Like I show you here, that is not possible here, right? Because you are using the internal load balancer, the regional internal load balancer, right? But here it is possible. You can even if your backend service goes down, it will fail over to the another region. Okay, so this is the architectural differences of regional ILB and cross regional ILB, right? So if you look at the regional internal load balancer, so the load balancer is made up of all these component, whether it is a internal or external, whatever. So if you look at the regional internal load balancer, you have something called a forwarding rule and you have something called a backend service, right? So your forwarding rule is nothing, it is your front end, and your backend service is something that is used to attach your backends, which is a regional layer. That is the reason that the regional load balancer cannot do a failover, right? But in a cross regional load balancer, you have a load balancer with the two forwarding rules. You can see that one forwarding rule in a region A, and the second forwarding rule is in a region B. And then you have a backend service here, which is a global. Here you'll see a regional, but here is a global, right? Because of this of global nature, it can do a failover easily, right? And that is why all your backends are attached to this single global backend service. And one more thing that we should you know um, keep in mind, that we use the proxy only subnets. The proxy only subnets in this diagram is basically provides a set of IP address that Google use to run your envoy proxy on your behalf. So you must create a proxy only subnet in each region of your VPC network where you use internal application load balancer, right? So proxy only subnets are only used for your envoy proxy, not for your backends. So whatever traffic that gets that gets to your backend service is going to be initiated from your proxy only subnet range. We will cover this in our demo. So I hope so far. So these things are clear between the regional ILB and the cross regional ILB. So this is the differences, the functional differences between internal application load balancer and the cross regional internal application load balancer. So here you'll see some of the differences, like VIP. In VIP is nothing; it is a front end IP address which is allocated from a subnet in a specific Google Cloud region, and here also allocated from a specific Google Cloud region. So client access in a regional internal application load balancer, not globally accessible by default. You can you can optionally enable the global access, and here it is always a global accessible, right? So client can come from the any Google Cloud region and can send the traffic to your load balancer. And these are the regional backend as I talked about, and here you get the global backend service, here you get the regional backend service, the high availabilities, so automatic failover to healthy backends in the same region only. So here you can get the failover to the healthy backends in the different region as well, right? So you'll get a failover, a regional failover kind of features here. So these are the basic difference. Yeah, you can find it, I can find it on their Google official documentation as well. So cross-regional ILB with the managed instance group. So in this demo, we are going to see how to use cross-regional ILB with the managed instance group, or you can also use with your Kubernetes engine or Cloud Run, Cloud Function, now, or your backend instance in your on-prem server. So you can use that. But here I'm going to show you the demo for the managed instance group, right? So let's just understand this architecture, and then I will show you the Terraform code, how we can use the Terraform code to deploy everything from the Terraform code only. So in this design, we have a network, LB network, and we have two regions, US West 1 and US East 1. And then we are going to create here we are going to create an internal cross-regional internal application load balancer, which we got two forwarding rules or the front end, and then we will also create a backend in each region. So we are using the managed instance group here, and we are also using the managed instance group in the US East region. Then we create our backend service, global backend service, which will target to both your backends in both the regions, US West 1 and US East 1. Then we have some the URL map, which is also is going to be global, and the target proxy. Target proxy is nothing, it is a HTTP or HTTPS kind of thing, which is here you can use global. So if you want, you can use a HTTPS maybe, then you need to attach some sort of certificates, right? And we have a proxy only subnet regional, so we will create a proxy only subnet in each region, so that whenever the traffic yeah, whenever a client sends a traffic to your load balancer, it gets terminate here, and the new session gets started from your proxy only subnet range to your backend service, right? So overall, this is the structure that we are going to deploy. And on your very left hand side, you have two client VM. We will deploy two client VM in each region, and we will try to ping the front this internal load balancer front end IP, and then see if the user can be able to serve the web page or not, right? So, and we also do some failover here. We will simulate some regional outage. Let's say US West 1, this backend goes down, then this client VM will continue to serve continue to consume your web page from the backend service in from the US East region, right? So we will see that. And we will also use the DNS policy manager. We will create some internal domain name, let's say my app something.example.com, because your client never use the IP, your client use the DNS name, right? And based on the DNS name or geolocation policy, the traffic gets routed based on the user's location, user's nearest location, right? So let's see that. So this is again the differences. So let's see the demo. I hope so far everything is clear now. What is the differences between the internal load balancer and the cross regional? So let me just zoom it. Uh, okay, so here is my Terraform code that we will use to deploy. So what we are doing, we are creating a VPC The VPC name is going to be my VPC, and here we are going to create two subnets. The first subnet is uh, in the US West region. This is going to be my subnet A. The range is going to be 10.1.2.0/24, and then we are also creating a proxy subnet, which I just talked about, in the same region, in the US West region, right? So two subnets in US West region. Similarly, we are going to create subnets in the US East region. One is for the a normal subnet, and another is for the proxy subnet. The If you can see the range, the 10.1.3.0/24, and also the proxy range I'm setting, I'm taking 10.129, and for US East I'm taking 10.130. Right, so for each region you are going to deploy a two subnet, one the normal subnet and the another is the proxy subnet. And then we are going to create a firewall rule. So this firewall rule is saying, if we basically a health check rules, which is used to check the health of your backend service from this IP range, and this source IP range are basically owned by the Google Cloud systems, which continuously checking your backend service health check. Right, so this is the first rule. The second rule I'm using to open some of the port like 22 for SSH, uh, basically to connect my client 1 and client 2. And this is the third firewall rule. This firewall rule, which I was talking about, when a traffic is initiate from your proxy subnet to your backend service. If I show you the design here again, so 1 second. So this is the proxy only subnet range, which has got 10.129 range, and this has got 10.130 range. So from here to your backend service, you need to open some firewall rule, right? So this is how I'm going to open an ingress firewall rule from this range, right? 10.129 and 10.130, right? This is the subnet proxy subnet range, which we have already defined in our US West region, which is this, and US East region, which is this block, right? And then finally, we are okay. So after that firewall, we are going to create and managed instance group, right? So we are using this template, and in template we will define like what is the name of your instance name, and then the machine type, region, tags, and all this thing. The startup script, basically the startup script is used to deploy your web server on your instance, right? So we are using this web1.sh. This is, we already define our the automation here. So in your, so this instance is going to get your startup script from this file, right? And we are also creating a managed instance group in your US East region. The same steps. The only difference is that the reason is different, right? So here also we are using the web one. Now we are creating the managed instance group, right? Now the template is defined. Now we are creating the managed instance group where we will use our template, and this is the managed instance group, and this is the managed instance group for the US West one, and this is the managed instance group in US East one, right? Let me make it one, because 1 second. Just make it one. Demo. And finally, we are going to deploy our load balancer. The load balancer has a many component like health check, and then the backend service, right? This is the global backend service, and we are going to attach two backends here. One is from US West region, and another is from the US East region. Then the URL mapping, and then we are using the target proxy. And here the forwarding rule, right? The forwarding rule, which means a single internal application load balancer gets two forwarding rules. Forwarding rule A, which is
It seems there is a glitch at Sumit's end, so let's wait for him to rejoin. I would take this opportunity to thank Communal as a platform for supporting this community event. Additionally, I would like to thank all the GDG India organizing team for again supporting us throughout the way. I would like to thank all the organizers of Google Developers Group across India and the global team. Additionally, I would specifically wants to thank to Uttam, Karthik, Manu, Harsh, Arun, everyone in the team for being with us throughout this journey. Let's wait for Sumit to rejoin and then we can continue with the.
Yeah. Hi, Mayur. I'm back. Am I audible?
Yes, you are.
Sorry, there was some glitch.
No, not to worry. You can please continue from where you
Okay,
left.
so I'm resharing my screen again. Just a minute. Is it visible? My screen is visible?
Yes, it is.
Okay, so I was talking about the forwarding rule. So we are going to create a forwarding rule in US West and the and in the US East. So this forwarding rule, basically a front end which will get an internal IP address, the endpoint IP address, which is going to be 10.1.299 and 10.1.399 for the US East region. And if you see that the load balancing scheme is internal managed, and the network, the target is going to be your HTTP, and the subnet is subnet A. Similarly, for forwarding rule for the US East region as well. So everything is perfect. If everything is perfect, we should be able to deploy our infrastructure with this code. So to initiate, to run your code, you first need to initiate with the terraform init command, and then you can use form terraform validate to check whether your code is having any errors. If there are any errors, it will show you, otherwise it will show you as success, right? And then we are able to use terraform plan, so you can see your plan. This plan will show you what resource you are going to deploy. So you will just review it with your manager or your senior, and then you can, if everything is fine, then you can run it. So let me just apply it. Saying yes. So you can see that it has started deploying your network, the health check first. It's creating your network, creating your health check, and now creating your subnets and proxy subnets, the firewall rules. If you want to see, you can just log in. I can log into my console, and here if I go to VPC network, you will see some of the resource. Oh, let me just change the project. This is my project. So you can see that my VPC has been created with 4 subnets, still creating remaining resource. So you can see that this is my VPC, and it has got 2 subnets. One is in US West region and another in US East region with this IP range. And I told you like the proxy subnet. So here you get a proxy subnet, a regional proxy subnet for your regions, US West one and US East one, which has got this IP range 10.130 and 10.129. And now you can see that it is creating your instance template and instance group. So let's just cross verify. You go to your compute engine VM instance, and here you can see that one of your VM machine is going to deploy in US West A region. It will deploy in US East region as well. So this is your instance template. The instance template global for both the regions, and the instance group. This is your instance group, right? The managed instance group, which is using this template, right? Now if you go to VM instance, so it is still creating the forwarding rules. Let's wait. Yeah. So now you have 2 VM, the 2 web servers are ready. One in US West one and another is in US East one, right? And here you can see that this is the internal IP, the static internal IP has got assigned to your web servers, and this is the public IP, right? This is the public IP just for the testing. If you just want to test it, you can test it here, right? So this is the page that will be served from these web servers. The IP address, the server, the host name, and the server location, right? So let's just wait for this to finish. All right, so here you can see that your forwarding rules and everything has been completed. 18 resource has been added. So let's just check the remaining resource. So we have the load balancer also ready. If you go to the network service and the load balancing, here you can see that your load balancer name, which is your internal application load balancer. You can see that this is the load balancer type is application, the access type is internal, the protocol is HTTP, and your one global backend service with 2 instance group, right? So if you just click on that, and remember that this the forwarding rules and this global backend service, whatever that we have deployed from the Terraform, is currently not available in the GUI, in the GUI mode. So if you try to create a forwarding rule using the GUI, using the console, you won't get that option, because this service is still in the preview mode. Once it is for the general availability, then you will get those options, right? So so here you can see that we have got 2 front ends, as I talked about. This is a single load balancer, and we have got 2 front end. One is for US West region and another is for US East region. This is the static IP which we have defined in our code, and this is the backend where we are using the global backend service. This is the global backend service name, and the endpoint protocol is HTTP, and this is the health check, and this is the backend, which is a backend type of instance group. One is in US West one region and another is in US East region, right? So now if everything is fine, we should be able to serve the page when a client from your internal network is going to hit this IP or the URL, right? And let's do one thing. Instead of hitting this IP, let's create a DNS, right? DNS policy, right? So we have got two IPs. So let's use this example.com. And I already previously created this record uh, where I can show you. Just edit it. So here, um, the DNS name I'm going to set myapp.example.com. So my clients will use this DNS name instead of the IP. And the routing policy data, I'm saying geolocation policy routing data, which means if a user the source is US East 1, right, the load balancer is going to the forwarding rule, or the front end is going to be here 10.1.3.99, right, which I can show you again in the next tab. So for US East, the IP is 10.1.3.99, right? So this is what I'm saying here. If a user or the source reason is US East 1, then the traffic should hit or use this front end, right? And similarly for US West 1, we should use this forwarding rule 10.1.2.99, right? And this is the review mode. This is the DNS name, and the routing policy type is geolocation, and this is the routing data, right? So I'm just going to cancel it because it is already there. So now let's quickly deploy a client VM as per the architecture. Everything is done. Your backends are done. Your global backend service are done. Proxy only subnet are also deployed. URL map, target proxy, and two front ends, right, are also deployed. Now we will create a client VM, right? The DNS policy is also done. Now we will create a client VM in each region and test it out. So let's deploy using the Cloud Shell. So let me just wait for a second. I don't know why it is taking too much time. Let's wait for another minute. If it doesn't come up, then we can use. Okay. So let's deploy a client machine 1 in a US West 1 region. Okay. So I'm going to just copy paste this CLI command, Google Cloud CLI command. So here I'm going to create a VM with this name L7 ILB client US West 1A, right? So let's just create it. What happened? Okay, sorry, my bad. Just give me a second. Now create a second client VM machine in US East 1. Here you see your two more virtual machines. Yeah. So if you just refresh it, you can see your client machine, which is in US West 1 and US East 1 in both the regions. So let's quickly SSH into this. I'm just SSH into the US West region and SSH to the US East as well. So I'll show you like how the failover works in a cross-regional internal load balancer, which is not feasible in the your traditional regional internal load balancer, right? So this is on your right hand side. This is the US, the client VM in US East, and on the left hand side, this is a client VM in your US West one, right? So I'm going to curl my DNS name, which is myapp.example.com. Sorry, let me check the DNS name again. What was the DNS name? My app. My app.example. Just a second. What is the problem? Let me see. Okay, I think the network is not there, I guess. Yeah. So I forgot to attach my VPC network. So you need to attach this the DNS zone to your specific VPC network where your backend service and client VMs are there, right? So this part was missed. So right, if you now able to curl, you should be able to do that. So this is good, right? We are facing issues on live, right? So this is great that we are troubleshooting these issues on live. So here you can see that on when a client VM is trying to hit your internal load balancer on this DNS name, the DNS is forwarding the request to your West one front end, and your page is getting served from the US West one region. You can see that this is your zone name, and this is the your VM name, right, which is in US West one region. However, if the client is in your US East region sending a request to your DNS, the your load balancer is sending the request to the backend which is in the US East region, and that is why you are getting your page served from the US East one, right? So you can see that this is the VM name, Z1JR. If you just see that Z1JR, this is in the US East one. So this is the beauty of using the cross region internal load balancer, that it redirect the traffic nearest to the end user location. Let's say you are in US West one, right? Let's say you are hitting the traffic from somewhere from the Europe, let's say from France. The user request will always be get served from the your nearest backend service, right? Let's say if I try to create a one more VM, let's say in India or in Mumbai, and then try to curl this DNS name, then I will be served from this the backend service which is in USC, because that is something nearest, right? Maybe. So that is how we can use that. Now let's assume, um, let's just uh, close this the US East one. So now what I'm going to do, I'm going to you know stop this backend service in the US West one. Now what happened when I stop this backend machine in this US West one? My traffic will divert it to the US East one. So let's do that. How we can do that? Okay, let me. Okay, let me just SSH to this machine, or maybe simply you can go to your load balancer. Okay, uh, this load balancer, and let's stop this US West one. Okay, So I'm going to remove from this group, right? It means I'm simulating the environment where my backend is not available. Now what happened? Now this VM, which is directing to my US West instance, right, which is the this one, drwp is now down. Now let's try to hit it. What happened? You can see that your request is now forwarding to the US East web server, which is JR, right? Immediately it has noticed that the backend service in the US West region is down. So it now diverting all the traffic to the US East region, right? So this is how you can achieve the failover in your cross regional internal application load balancer, right? So that's it for now. This is you can use this architecture in your real world use case. So if you have any questions, please feel free to put in the chat. I will be happy to answer it. Thank you. Over to you, Mayur. Yeah, Mayur.
Hey, hi Sumit.
Yeah, so I'm done with the demo. If there are any questions, let me know. I can answer it.
I do not see questions as such. I believe that you covered everything.
You are breaking, Mayur. I
Uh,
think there is some latency issue. I don't know. Network latency issues. You're breaking.
so there was a glitch in between the session, but now it's all good.
Okay, now I can hear you.
I
Yeah,
can
yeah.
see the feed. I can see the feed going live on YouTube. So we are just about the time also. Uh, Thank you so much for joining us and enriching the community with this very good session on cross regional load balancing. I would appreciate you joining us again in near future with more topics on GCP tech and other Google Cloud technologies. Uh, Additionally, I would again like to thank the whole Google Developers Group India organizing team and Communal, our community platform partner, for providing us their platform to host this session and to make this YouTube live stream possible. Thank you. Thank you everyone for joining us, whether you have joined us being part of GTG Cloud Bhopal or in general on YouTube, through LinkedIn, through Instagram pages, from any medium. If you have joined, I would like to thank you for joining us. Uh, I see that Sumit have shared his QR code on the screen. Please feel free to connect with him directly on YouTube, on his channel, The Cloud Baba, or you can connect with him on LinkedIn. He regularly posts good blogs, I would say, on variety of GCP services. So it would be a great medium to increase your knowledge on Google Cloud. Thank you. We will connect again with a new featured speaker on this expert talk series. Till then, take care, keep learning. See you in the cloud. Thank you.
Thank you. Bye bye.
Bye.